Hello, and welcome to our lesson on adding real numbers today. This is a concept that will carry you through for the rest of your work in algebra and beyond. One of the things I want to focus on in this video is the development of a mental or visual model for what we're going to do. Studies show that really successful math students have efficient ways of visualizing numbers, meaning that they can picture in their heads how numbers are related to each other, how they break apart, combine, all the different operations we can do with them. So if your goal is to not just get through a section or a concept or a homework assignment, but to actually become a successful math student, this is something that's going to be really worth your time. So the number line is our best friend, okay? I've mentioned that in a previous video where we introduced what the real numbers are. So the number line is going to give you a way of picturing the numbers and where they are relative to each other and what we're doing when we're adding them. The first number is our starting location. The second number tells us if we're moving left or right. So positive numbers are going to move us to the right, meaning if we're adding a positive, then we're going to go towards greater values. Negative numbers are going to move us left on the number line towards smaller values. So let's start with something you already know. Now, this is going all the way back to first grade. I hope everyone watching this video does know that 2 plus 4 is 6 and 1 plus 3 is 4. So this is not about whether or not you can add those numbers. This is about the model. Okay, so bear with me, and you just kind of have to trust that I've seen a lot of math students and I've seen a lot of what goes wrong later on in math. So the first number is our starting point. Now, what I will typically do is I will just simply put the 2 on the number line because I don't need the rest of the numbers. I'm not really big into writing numbers that I don't need. But some people like to have the context of the other numbers around the 2. So what I'll do for the first problems here is I'll probably do a more detailed number line, and then as we get further in the lesson, I'll truncate it to more of what I would do. So the first number gives us our starting point, which is the 2. And then the plus 4 tells us that on the number line, we are going to move to the right 4 units. So starting at the 2, I count 1, 2, 3, 4 units. Okay, 4 units to the right. And what you notice is that that lands me at the 6. Okay, and so we already knew that 2 plus 4 was 6. This is not about whether or not you know those answers. This is about the model. So we have a starting point, and we're going to move to the right because I am adding a positive number, which means that my result is going to be a greater value. Same thing over here. We'll do the 1. And if you need to see like the 0 and the -1, okay, we can do that. So we'll put a little context on that number line. And the 1 is our starting value. And then the plus 3 means we're going to move 3 to the right. So 1, 2, 3. And you can see that that lands me at the 4, which again, you already knew. So let that sink in for a second. I know I can be wordy and my videos can be a little bit long sometimes. I wouldn't stop here if I didn't think it was worth it for you to let that sink in that, okay, we're on the number line and we're moving in a particular direction. So how is that going to play out with some negatives? So if you are adding a negative, what that means is that you are going to be moving left on the number line. So the first number gives us that starting point, and the second number tells us which direction we're going to go. So because I know that that's a negative, I know I'm going to be moving to the left. So what I'm going to do is put my 2 over towards the right end of my number line. And I'm going to be moving left. So we'll give ourselves some space here and counting down 2, 0, -1, -2, -3, -4, and -5. And the 2 is my starting location, and I'm going to move 5 to the left. 1, 2, 3, 4, 5, and that lands me right there at -3. Again, notice we have the starting point and then we have the direction that we're going to move. Now for this next one, I'll show you more what I would do using the number line here, because I am not about extra work, nor am I about having my students do extra work or anybody watching my videos online. Okay, we do not need extra work. So the -5 is my starting point, and because this is a +6, I know I'm going to be moving to the right. So I'm going to put my -5 towards the left end of what I'm writing here, and then I'm going to just simply count the 6 units. So I know I'm going to be moving to the right 6, so I'm just going to tick it off like this. 1, 2, 3, 4, 5, 6, and then I'll count them after I do that. So we can count -5, -4, -3, -2, -1, 0, 1. If you need to fill that in, you can do that. That's a little bit cramped here. I'm sorry. -1, 0, 1. And so I land at 1. -5 plus 6 is +1. Last but not least, okay, I've got the negative there. I know that means I'm going to be moving left. I'm going to start at -2, and I'm going to count 5 this time to the left. 1, 2, 3, 4, 5. And then I just need to figure out where that is, which, would be awesome is if I counted in the right direction. So let's try that again. I will use that as a teachable moment, but I'm moving to the left, so that's -3, -4, -5, -6, and -7. So I landed at -7. Now, what I just did there, because I did say I want to use a teachable moment, I was making my own number line, and I accidentally started counting in the wrong direction. Errors with signed numbers are the most common mistakes at any and all levels of math. So it doesn't matter whether you were just starting negative numbers in pre-algebra or algebra 1, or whether you are in graduate school and you have been dealing with negative numbers like forever, okay, for many, many, many years. Making a mistake like what I just did, counting the wrong direction, flipping something in your head, putting a negative where there shouldn't be one, or like getting rid of a negative, dropping a negative off, super, super common things, okay? So don't beat yourself up if you do it. I'm not mad at myself that I just did that. I just recognized I made a mistake and I went and fixed it. Okay, so a quick word about rules. Many teachers will teach this skill by presenting students with rules to follow. And if you're a student and you're watching this, your teacher might have presented it that way. So you may have heard something like subtract and take the sign of the larger. Okay, so you just subtract the two numbers, you ignore what's positive and negative, you subtract them, and then whichever of those two numbers was the bigger number, that's the sign of your answer. So if the bigger number was positive, the answer is positive. If the bigger number is negative, the answer is negative. Now, I really don't like that because I think it gets into messing up with our idea of what's bigger and what's smaller. Another way you might hear some of these rules is adding two negatives gives you a negative. Okay, so you'll hear these rules and you might have had this taught to you with rules. Now, while these rules certainly work, I have two main objections to teaching this concept with rules. First, they are very forgettable if you do not know where they come from. So if somebody just tells you subtract these and take this sign, and you have no idea why you should be subtracting them and taking that sign, you are going to forget them, okay? They also contribute to a mindset that math is all about rules to memorize and not concepts to master. We are not here to memorize a bunch of rules, okay? So no on a bunch of rules. We are here to master the concepts. And if you master the concepts, you will find that every next step you take in your math journey is going to be so much easier. The other reason I object to teaching this with rules is that they are often confused with the rules for multiplying. So you end up with a set of rules for adding, and then you have this separate set of rules for multiplying. And neither of the sets of rules make sense because you don't know where they came from or why you were doing it. And then you get them confused because I'll tell you, if you multiply two negatives, you actually don't get a negative if you haven't seen that rule. So it is well worth your time to focus on that number line. I am going to box this in, okay? Even if that means taking longer to do the problems at the outset, it is well worth your time to focus on that number line so that you are literally picturing the adding in your head and not trying to remember a rule, because that number line is never going to change and you're not going to get the number line confused with some other number line. It will always work. So I really felt like I needed to make that plug. So this also applies to expressions with variables. We call this combining like terms, and you will hear this all the time. In my own classes, I often abbreviate this CLT because I do not like to write combining like terms. But what combining like terms is, it's referring to terms that have the same variable parts. So we know from our previous study in algebra that 4x means 4 times x, and x is some unknown number. So what we have going on here on the left here is we have two things that are being multiplied by an x and two things that are not being multiplied by the x. And because I don't know what x is, I can't really do anything between the two groups. So I've got the stuff that's stuck here with an x and the stuff that's stuck here without an x. But what I can do is I can simplify or combine the pieces that don't have an x together and the pieces that do have the x together. So what that looks like is this. So I've got a -3, and I'm going to add -4, which means I'm going to go 4 to the left. So 1, 2, 3, 4, and we look at where that's going to put us, and that is going to put us at a -7. I can do the same thing with the x's. So I have -2x's, and I want to move 4 x's to the right because that was positive. So 1, 2, 3, 4. And you can just actually just count the constants. Like, you don't need to put the variables there, but so that lands me over here at 2x. And so this concept also works if you happen to have a variable. Usually I don't think of it in terms of -2x and 4x. Like, I just deal with the -2 plus 4, and -2 plus 4 is 2, and then I know the x is there, so that's fine. But you can put the x on the number line if you'd like. Few properties of addition. First one, a plus b equals b plus a. That's a commutative property. You have almost certainly, if you're in an algebra class, have heard that word before. And it pretty much means that you can switch the order of things. So if you have 2 plus 3, that is the same thing as 3 plus 2. It doesn't change. And that also works with your negative numbers. So 5 plus -4 is the same as -4 plus 5. Okay, so that's what that property means. A plus 0 is equal to A. Okay, sometimes you'll hear that called the identity property. A plus -A is equal to 0. And another word for opposites is additive inverses. Now, the chances that you need that vocabulary, additive inverses, is kind of small, but there it is. So opposites are also known as additive inverses, meaning that when you add them, you get the what's called the additive identity, okay, which is 0. And last but not least, negative of b plus a is equal to negative b plus negative a. This one you are better off discovering on your own, I think, rather than trying to memorize it as a property. So we could pick some numbers for fun. We could say -2 plus 5 and just compare that with -2 plus -5. On the left, we would do our order of operations, which would mean we would do the parentheses first. So 2 plus 5 is 7, leaving me with -7 on the left. And then we can do on the right -2, and then we're going to go left 5. So 1, 2, 3, 4, 5. And that would put me at the -7 on the other side. And what you can do is just do a lot of these with, like, pick some numbers, like pick whatever numbers make you feel warm and fuzzy inside, and just like work that out and convince yourself that that's true. Another way people might think of that is distributing the negative, but we haven't really talked about distribution yet, so we won't go there at this time. Okay, we can use these properties without even realizing it, and you will get to the point, but I think it's good for you guys to notice just what's happening, like why we're allowed to do what we do. So in this problem over here, what I'm going to do is a little bit of juggling some stuff around. So I am going to take this 3 and this -4x, and I'm just going to switch the places. So I'm going to use that commutative property that says 3 plus -4x is the same as -4x plus 3. So I'm just going to move those. And then I am going to do the same thing right here. Okay, I'm going to use the commutative property again, and 3 plus negative 3x is the same as negative 3x plus 3. So I'm going to x there. Okay, and what that does is that essentially regroups so that my like terms are together. So my x's are together and my constants are together. And that just can visually allow us to engage like some of our skills for adding. Negative 4x plus negative 3x. Okay, so negative 4x, and then I'm going to go negative 3x to the left. 1, 2, 3, and that's going to put me at negative 7x. And I think we're probably okay doing 3 plus 7. We don't need to use the number line for that. And that becomes a plus 10. So what we actually do most of the time in math is we do not go through that process. So if you're thinking, oh my word, is that what I'm supposed to do? No, not at all. But what we do is we will take the 3 and the 7, and we'll just kind of look at that and say, okay, those are the like terms. So this is 3 plus 7, and we'll jump right down to the 10. And the negative 4x and the negative 3x were already next to each other, so we can get the negative 7x. But what we are doing is we're using the commutative property. We're using this property that allows us to kind of juggle stuff around in the expression. We just don't even realize that we're doing it. All right. A few other ideas for models. So you might have seen positive and negative numbers, yardage in football, where gaining yards is positive and losing yards is negative. So if you're a big football fan, you might want to picture all your adding of signed numbers with your positive and negative numbers as gaining and losing yards in a football game. Money, so earning money is positive, spending money is negative, and if you spend more money than you earn, yes, you will end up below a 0. So money is a good model to use in your head. Temperature, we did a word problem on this not long ago. So getting warmer is positive, getting colder is negative. And yes, you can go below 0. So if you get really cold. And then this one is a little bit maybe more abstract, but we can use this with anything that has direction. So this can be defined different ways, but it could be something like moving towards home is positive and moving away from your home is negative. And that would be unique to a specific word problem. So somebody would define a place and say, this is the 0 point, and moving in this direction means it's the positive direction, and moving in this direction is the negative direction. For those of you that are physics bound, you will do that all the time in physics, but the concept starts here in Algebra 1. All right, please, if you found this video helpful, please give it a like. For content updates, please subscribe to the channel, and please comment and let me know if there are specific topics you'd like to see me cover in my videos, and I will be more than happy to make videos that are going to help the people that are viewing the channel.